All right, I am going to do number 30 here on page 464 as soon as this thing zooms in. There we go. All right, number 30, let's read it first. This is a vector problem. A canoe heading 30 degrees west of north is being paddled at a rate of 7 miles per hour. The current is pushing the canoe 20 miles south of west at a rate of 3 miles per hour. Find the resulting speed and direction of the canoe. So there's two things at play here. There's a canoe, and we know it's going at 7 miles per hour. It is going 30 degrees west of north. So just drawing our basic north, south, west, east. So it's kind of going like this, 30 degrees west of north. And then there is a current. The river flow, it has a magnitude of 3 miles per hour. This is going 20 degrees south of west. So this guy is pushing like this, the current. And you'd have a 20 degrees right there. That's really small. I know that's hard to see. All right. So what we're going to do, and then so now you've got a canoe going this way. You've got current pushing it this way. What is the result? What is the overall effect? And the direction of the canoe. So let's try to just draw this as vectors here. All right. So we've got north, south, west, east. I will use the red for the canoe. So this canoe is going like this. There it is. It is 30 degrees west of the north line. So I'll put a 30 degrees right in there. And it is 7 miles per hour. That is the magnitude. I'm going to use blue here for the river current. And it is going like this. Not quite as long because it is going only 3 miles per hour. And it is 20 degrees south of the west line. So you figured if I'm going this way and the river's pushing us this way, that's kind of a compromise in between. Where is it? Well, that's the question. What we're going to do is figure out these endpoints here. Once we know the endpoints, canoe going this way, river current going this way, we're going to add the endpoints, and then that would be the actual path of the canoe. So for the canoe, the red line here, I'm just going to focus in on this triangle. I'm not going to make it as big. There's 7. This is 30 degrees. I need to figure out this X and this Y. This is for the canoe. I'm going to get this ending location point. So if I stand here at 30 degrees and this is 7, usually I put it on the outside, so I'm going to put this on the outside of the triangle. This would be for X here, which is right next door. Actually, let's switch this because X is never up and down. That's Y. This is X. For X, opposite hypotenuse. That is sine 30 degrees, opposite X, going left to right, hypotenuse is 7. Throw that in the calculator and you will get 3.5. To get the Y value, the up and down number, this is adjacent, there's the hypotenuse, you would say cosine of 30 degrees is Y over 7. Throw that in the calculator and you get 6.06. So, looking back here, what is this is the canoe. The ordered pair is X is negative 3.5, comma, positive 6.06. West and north. West and north. Okay. Then there is the blue river current. Let's try to draw this guy here. Not quite the same as the original triangle here. We have a 20-degree angle here. We have the current, that hypotenuse magnitude is 3. We're going to figure out left to right x and up and down y. So to figure out x, stand at 20 degrees, we're going to say cosine 20 degrees is adjacent over hypotenuse. And then the calculator will spit out 2.819. Opposite hypotenuse for that y value. So the sine of 20 degrees is opposite over hypotenuse. The calculator, if you go to your calculator, it'll spit out 1.03. Sorry, I've been kind of a little bit inconsistent here. Some of these are in rounded to the 10th and some are rounded to the 100th. Oh well. Okay, so here is the current. Let's look back if things should be negative. X should be negative, Y should be negative. So negative 2.82, I'll round that, comma negative 1.03. Okay, so I went negative west, negative south. Okay, now we're going to add the two currents together, and this is going to be the actual path, the resulting speed here. If I add this, you will get approximately, depending on how you do add these two x's, you actually dig deeper into the negative 3.2, comma positive 5.03. Okay, so that is the result. So really, and I'm going to go green, this is negative 6.32, positive 5. All right, so it'll be something like this. It's out here in green. Whoops. All right. It didn't quite go as north as the previous one. It gets pushed a little bit, but it actually goes further and further west because they're both going west. So the boat goes west, the current pushes it west, doesn't go as north as it wants to, and so that's the result right there. Negative 6.3 and so forth, 5.03. So now the question is, what is the result speed of this green line and the direction? So I'm going to kind of redraw this green line here. We're going to figure out the speed of that guy, which is the magnitude. We have two things that are important to us right here with these results. We have left to right is 6.32. I know it says negative, but we really don't need the negative number. Up and down is 5.03. So it's like 503 this way, 632 this way. Okay, so I want to get the resulting speed. This is the overall thing that we're trying to get to, which also is the magnitude. You'll notice the right triangle there. We're going to say a squared plus b squared is equal to c squared. Throw that in your calculator, and this will end up being 8.1 miles per hour. 8.1 miles per hour. So the guy can actually canoe at 7 miles an hour. He's not actually fighting the current. The current, he's going west, the current is going west. So he actually picks up speed. You know, the canoe without a current, he's actually picking up more speed. The problem is he's not getting as north as he wants to because he's fighting the current in terms of the direction. He's not fighting the current in terms of speed because it is pushing him, but it's pushing him off kilter. All right? And so we are going to figure out this angle here, which we will call angle A. Let me scroll up a little bit. And so to figure out the direction, we need angle A here. So we would say, I got opposite, I got adjacent. Angle A is tangent, -1, opposite over adjacent. Do the inverse tangent there, and you will get 38.5 degrees. So this is 38.5 degrees north of the west line. North of west. So here's the direction. Here's the actual speed of the canoe that's fighting the river current. Number 30.